welcome to today's webinar. Let's see, you should be able to see my screen now. And today we're going to be talking about building agentic systems on Azure with MCP, from DevOps to an intelligent cloud. My name is Scott Rosenberg. I'm the lead architect in the CTO office at TeraSky, a global solution integrator. And today I'm with Yaniv.
Hey, hello everyone. I'm Yaniv Norman. I'm from Microsoft CTO's office in Israel. Happy to be here, Scott.
Exactly. No, it's awesome to be here together. And let's get started here. Hold on. There we go. So first of all, let's just level set here on what is MCP even before we get started. Deeping dive into the details. Let's just give it the quick definition here. Model Context Protocol really is the emerging industry standard for connecting any AI agent out there to our enterprise systems, right? And this is massively adopted across the entire industry. Originally created by Anthropic, it was donated to the Linux Foundation into a new foundation all surrounding AI, with Microsoft being heavily involved, OpenAI, Anthropic, Google. It's really a industry standard that's being built that is probably taken off faster than any other standard in the industry in history, almost. And MCP really is about standardizing how AI agents discover and use enterprise tool and data, right? If we think about it, we have all of our chat interfaces or code editors like Copilot, and we have our AI-enabled applications, right? And those are really our interfaces. But on the other hand, we have datas, and we have file stores, and we have all of our different developer tools, be it GitHub or Playwright and things like that. And we also have our productivity tools. And MCP really is that glue that allows us to standardize how we connect our interface with those backend systems in a standardized way. So I don't need to build an integration for GitHub into Copilot, another one for Cursor, another one for Claude Code, another one for ChatGPT, and another one for my custom application. How do we really standardize this interface? Now, there are multiple types of MCP servers, right? We have local and remote. And when MCP started, it really was this STDIO transport, right? Standard input output transport. And this is a local MCP. This is what we see a lot of people doing, right? In the end, it runs locally on my machine. You run an MCP server locally, you connect it to your agent, and it works. This is great for local process communication, but it's limited to same machine operations. This is the same challenge that we see in enterprises of, can I run Docker on my local machine? How do I make sure that people are running trusted code? How do I make sure that the MCP isn't some vulnerable malware that I'm running? How do I actually push a standard out to my organization when it's just random things running on people's machines? It can be a Python application, it can be TypeScript, it can be Go, it can be a container, it can be so many different ways, and this has created complexity. So what the MCP specification came out with next was HTTP with SSE, which is server sent events. It's basically a client server to client streaming protocol that allowed us to connect to remote MCPs. I would deploy an MCP somewhere, be that Kubernetes, be that hosted in Azure, for example. We would host our MCPs. They would expose a protocol following SSE over HTTP, and there would be HTTP post clients between the client and server sending these messages. And this was really the first enablement of remote MCPs, which was great. But it had a lot of limitations, and it required keeping a constant connection state with the server. It had a lot of complications in the back-end logic that just made it not really feasible. So MCP came out with the streamable HTTP protocol, and this was released in March 2025. And it enables a stateless server architecture. Basically, every connection can be handled on its own. There's no constant connection needed. We've removed that long-term connection requirement. It's way more flexible for cloud and serverless deployments because of this. And it's ideal for modern web app architecture patterns. And this is really where we're seeing the industry moving, is almost completely into that streamable HTTP world. And moving away, SSE is deprecated and STDIO is great for dev, but really in production use cases, it just doesn't work well. So with that, I want to pass it off to you, Yaniv, to talk about MCP at Microsoft and what you guys are doing around this.
Thank you, Scott. Let me share my screen. Okay. Can you see the presentation now?
Now we see it. Yep.
Okay. So when we look at MCP at Microsoft, we have multiple tools that we have, and it sometimes can be overwhelming, the possibilities that we have within our products to host, use, and publish your own MCPs. So I will try to do some order in the chaos. So first of all, we have a couple of options for using MCP servers that Microsoft publishes to use in your own workflows and tools, which is the Azure MCP, like doing control plane options with the Azure provider. You have GitHub MCP, which is one of the popular MCP servers that can be used in all of those clients as well. You can basically use a logic app, which is like a kind of a workflow engine to expose your own kind of workflows as MCP servers as well. So you can use logic apps and compose logic apps as an MCP server and both host it and use it as part of the client as well. If you want to host your own MCP servers, of course, you have the functions that you can host, and we'll see a demo of that in a couple of minutes. You can expose MCP servers that you wrote on your own as a container app. And of course, use MCPs from clients. You have Microsoft-based clients. Of course, GitHub Copilot is one of the most popular assistants or AI assistant that you have inside VS Code. And of course, the agent service that then we will later see on. All of those options to deploy and use MCP servers inside Azure is both secured and governed by a generic API server that's called API management, and we'll drill down in a little bit. And of course, Enter ID to provide authentication and authorization to all of those services to secure them from anywhere. So when we look at the API management solution, you can expose APIs, generic APIs, and to unify all of those both services, if there's REST APIs that you are using inside your organization, and using all those protocols as well, or to unify LLM usage within your organization, providing a single control plane endpoint for exposing OpenAI endpoint, Anthropic, or different models that are hosted on different clouds, whether it's Google Vertex AI or AWS Bedrock. You can unify and then provide all this lifecycle management inside a single tool. And of course, expose, we added the capability to expose both an MCP server inside API management and to expose an open API as well, right? So you can use it as well to leverage A2A communication as well. But we'll focus about how do we provide the API management as a tool to expose a legacy-based REST API inside Azure. So you can take a REST API that you expose somewhere in the organization. It can be a function, and we'll see a demo of it later, and then expose it as an MCP protocol without the need to write your own MCP code, right? So you can take already existing REST API and then expose the functions that you want to use as an MCP endpoint for your clients, or you can take the MCP server itself and protect it with the authorization and authentication mechanism within the API management solution, and then expose it as a secure MCP server, right?
Right. And just one thing to mention on that, Yaniv, which is so critical, is that, you know, the MCP specification has had basically a new release every month. It is so rapidly moving forwards, and things are changing and all of that, that it's this ability to not need to deal with the specification, right? There's always the better way to build stuff native to a specific system, right? But with the spec moving so quickly, the ability to just work on something with standard open API framework And then when the MCP protocol stabilizes more and reaches a larger maturity, to then then you can go and actually write the full MCP servers, but not needing to do that at this point when it's still such a fluctuating, ecosystem is a huge benefit that Microsoft brings here.
Right. And it's super easy, and we'll show it in the demo itself, right? So you can take the API management and use it as an AI gateway solution to unify both the AI models, right? Whether it's hosted by Azure or different clouds as well. Unify your tools as well, if it's MCP or Open API specs, or if it's a different agents, right? So provide a buffer between your end customers or clients to your tools, and then protect them with full lifecycle management, governance to secure the activity of the APIs itself. So all of those services can be unified in a single place, and you can expose your private MCP registry using API Center, right? It's a different service that allows you to host your own private MCP registry with a full lifecycle management of both governance and integration with Entra ID, and it's free, right? So you can have your own custom portal with tools that are specific to your organization and publish them as a secure MCP registry for your VS Code clients to download and use all of those tools, right? So we will see 2 demos, right? And I record them for simplicity, and the more interesting use cases are later on. So both is using the AI Foundry, that is a tool to manage all of those LLM tools, and to create a custom model catalog in Foundry, and Scott will take us through the product itself in a little bit, and how to use MCP from your IDE, right? So let's start with the first one, right? So I take the Azure Foundry solution to host my own custom model and use it as a private endpoint in my VS Code, right? So we have a plugin, okay, for using the AI Foundry or the Azure Foundry inside VS Code, where you can explore both the model catalog and host your own custom models directly within the VS Code client itself. You can actually develop your own agents inside VS Code as well, right? So right now you're seeing that I'm deploying my own custom model, right? DeepSeek in this case, inside my project inside the Azure Foundry. And I can use it later on as an endpoint to leverage my own custom definition, right? And it can be any kind of generic models that support the OpenAI spec that can leverage both tools and MCP servers as well, and of course, agentic mode as well, right? So we have a list of models. So models can come directly from GitHub. You can host your own models within the GitHub Models AI Toolkit, right? So if you want to host it in GitHub as well, or you can host it in Azure Foundry or Foundry Local, right? You can host your own kind of models directly on your PC as well to expedite your own dev cycle, right? So enable the endpoint for DeepSeek, and now I can use it and select it inside the Copilot interface as well. So the second demo is how to use the GitHub MCP directly from the VS Code interface itself, right? So when I use VS Code, I have my MCP registry, and it can be hosted by publicly hosted by Microsoft, or it can be a private MCP registry with API Center, as we saw early on, and we have supported or created solutions that already support the MCP protocol. So I can do @MCP when I search for extensions. So every extension can implement the MCP interface and turn into an MCP tool that can be used by LLMs in GitHub Copilot as well. So I'm taking the GitHub and I'm doing federation from my user. Then we discover the tools that are available from the MCP itself, or all kinds of activities from GitHub API to basically get repositories, add new repository, create PR, and all of those good stuff that we have in GitHub API. And and then use it with the LLM to ask questions or to use with agentic mode with the GitHub MCP as well. And this is like a short demo of interacting with external systems within the GitHub Copilot interface. So back to you, Scott, for another demo, right? So let me stop the sharing. Yeah.
Awesome. So let's share this screen. Awesome. So if we actually take a look here for a moment at, what this all looks like in our environment, I'm going to talk just for a second. What I want to show is really, one of the nice things that Microsoft have built is all of this ecosystem, right? But this ecosystem doesn't live on its own, right? We just saw the GitHub MCP within Copilot and all of that. But we also have external systems in our companies. And for example, one of the big things that we see a lot is this whole idea of platform engineering and Backstage, right? And all of these great things. And one of the things that Backstage actually did is we've built a bunch of plugins here at TeraSky, for example, for Crossplane, Kyverno, different things like that. And we can see here, what would a developer experience be when they want to understand what's going on with their environment, right? So they go and they have their application, and this is based on, this has a Crossplane resource connected to it. And ooh, there's some policy violations coming from another tool called Kyverno. And yeah, I could dive in here. I could go to all these different tabs. And this is great, right? This is from a UI perspective, the user can get any data that they really care about, can come visualize things. I don't know why it's so slow right now. I apologize, but things don't really feel like loading. But basically, we get a full UI, right? We can visualize anything that we needed to directly in our system. But there are some challenges around that. And the reason is because I don't want my developer to need to context switch out to a UI. A UI is great, but Backstage already integrates all of this. So how do we bring this in? So what I'm going to do here is simply add a new MCP server. And I'm going to add an HTTP MCP server, a remote one using the Streamable HTTP. And I'm just going to give it here the URL. And this is going to be HTTP localhost for 7007/API/MCP actions/v1. And this is basically the endpoint that Backstage is exposing to me. Backstage also acts as an MCP server. I'm going to add this to my specific workspace that I'm working on right now. We can see that it got added. And ooh, the MCP server edition wants to authenticate. Would you like to allow it? Yeah, I'm going to allow that. And it's going to pop up Backstage for me. It's going to have me log in. As we saw, I was already logged in, so it recognized that from my browser because I have SSO set up. And I'm going to authorize, just like the GitHub pop-ups that you get all the time. We're going to authorize, and awesome. So now I'm authenticated, and I have 36 tools that are exposed to me right now from Backstage. And let's see what we could do here. So I have here my agent open, Copilot. I'm just going to say what Crossplane resources are connected to my component, my clustered app, and what policy violations are there on those resources, right? Very simple human term language that I'm trying to understand what's going on here. So this is going to run now. And what this is going to say is, okay, I got to get the Crossplane resources. And boom, it got all of the data for us, right? Much faster than a UI, loading, React components, all of that. Easier for the user and much quicker, right? Okay, so this runs. It says, cool, I got what I needed there. It also got my catalog entity. It says, oh, I should also go and get the Kyverno data of the actual policies, right? It's going to say, okay, all that's awesome. Now I want you to notice here on the left side, I have the streaming of my logs. And this is something very important. Everything we see here, this is Backstage running, and we can see everywhere that when it's checking the permissions that I have, when I'm running this from my MCP, it's checking against my user, scott@terasky.com. It is always using my identity across the board here. I can even ask it, for example, what tools do you have access to in this MCP server, right? And Copilot is going to return to us, ooh, I've got actually a bunch of tools. I have 36 of them. And it's going to return back. And this is where I want to show what the real power here is, which is that not only is everything done with my identity, but my identity is whether I'm talking to the Backstage catalog or Crossplane or Crow, right? Another project similar to Crossplane or Kyverno, or even on-prem solutions like VCF automation or VCF operations or configuration utilities or any plugins we add in, we can expose MCP through a single endpoint to our end users. All of this powered through models hosted in Azure Foundry. From GitHub Copilot, we can extend, and it's not a locked-in situation where I'm locked into what is exposed to us from Microsoft. Rather, Microsoft allows us to bring in anything that we want into this ecosystem, really unlocking that full potential, right? Which is extremely powerful. One second. All right. Having a screen share issue here.
Okay, so maybe I will take it away.
Yeah.
The next demo, yeah. So we have another demo for you. It's like, how do I create an MCP server inside Azure, right? So let me share my screen. So it's here. Entire screen. Yeah, share. Okay. Okay, right. So we want to show how can we create an MCP. So there are two main ways that I'm going to show in this case through the API management, as we discussed earlier. So I have my own function, right? I hosted it. It's called the Pet Clinic. If someone in the crowd knows this application, hola. It's a Spring demo application that we use to demonstrate the power of the Java Spring. So basically, it's a pet clinic kind of API management to schedule pets and owners, scheduling visitation through the veterinarians, right? So I have my owners, I'm an owner, right? I have my pet, it's Pikachu, right? I can edit the details, I can add veterinarians and everything. So as well as this application, which I AI slopped into a Python application, I added an API that allows me to use all of those activities within the UI through an API, right? So if I use the /API endpoint, I can go and get the owners, right? I can go and get the pets, right? But I haven't implemented an MCP yet, right? I have this API, but I want to expose it as an MCP server, right? So what is the best way that we can do that? And we showed that we can support this use case through the API management. So if I go to Azure and start up my API management solution, I have all these kind of tools, right? So the most useful tools that to implement this use case, we have the APIs, right? So first, I can buffer my API through API management to add authentication, to add scalability, to add kind of a security policy to govern who can access, or to add additional tokens to authenticate through my function, right? Because my function is a base kind of a hosting solution for my code. So I can go and add an API to the API management, and I can give it the Open API spec, right? So it's a standard manifest for code. So I've done that with my Pet Clinic application. So I have all of those operations that are supported by my API now hosted through the API management solution, right? So I can go into my API, add a policy, add authentication, or even test my API to make sure that the API works successfully, right? So if I do the send, I can get a response directly from my function, and that kind of buffers my function from the end user itself. So I can manage the lifecycle of the API configuration through the API management. But this is not all, right? I can take the MCP server tab and then expose the Pet Clinic API as an MCP server without actually writing the server or the MCP specs, right? So I can take the API itself, and the API management automatically selects the tools that are available through the API itself. So I can select which tool is actually active and can be used by the MCP users itself. Then we can expose, let's say, add a new pet owner, add a new visit, or get pets, or all of those activities that are available for the UI. It can also be activated for the MCP servers itself. In the settings itself, I give it an API endpoint, right? So I can give it a suffix. So the suffix is pet clinic, and then /MCP endpoint to connect with MCP itself. I can add additional authentication headers as well, or I can create policy to basically control how the API management process the requests for the interface itself. The second option to host the MCP servers is basically to give API management and already existing MCP servers that you implemented yourself, but you don't want to expose it directly to end customer or add additional security or policy layers within Azure itself. So I have another MCP server called Pizza MCP that implements an MCP for a pizza restaurant, right? And we will show it in a demo a couple of minutes from now as well. So I have two main options in API management to expose additional or an API spec or an existing MCP servers directly from a single interface itself. And then I can leverage it and use it within my environments to expose it to end customers themselves, right? So this is like the first demo. And now to you, Scott, for why MCPs are not enough.
Awesome. So, right, I think it's kind of funny that we're talking about MCPs and now we're talking about, why not MCPs, right? But like, if we really think about this,
if I need to summarize it, MCPs are just tools, right? They're not the entire thing, and you need to wrap it with additional staffs. And
right. So I think that MCPs aren't enough, right? And there's a few reasons for this, right? MCPs provide access, but they don't provide any intelligence, really, right? It connects tools and data, but it doesn't make decisions or orchestrate actions. Right now, there are agentic MCPs and all that, but then we're getting into agents already, right? So it's an MCP, a standard MCP is never really intelligent. They also typically lack memory and context persistence, right? Each interaction is stationary, right? There is no learning from our previous executions that have happened. We don't typically keep state around across sessions. There are ways of doing this, but it's all kind of each solution does it differently, and it's not really part of MCP. There is no autonomous execution as well, right? An MCP is something that something calls to do. It requires a human in the loop for every action, right? It can't just independently plan things, execute, adapt to the environment. It's a point solution. Give me data, do something for me. And there's another major issue. And this is the tool overload that just breaks agents, right? This is a major issue. And one of the reasons that, for example, one of the great capabilities that exist inside of VS Code Copilot, right, in GitHub Copilot, is my ability to actually filter and say, yeah, I added these 30 MCP servers, but I only want these two tools from this MCP server. I want this one from this MCP server. And I don't want, how many tools does the GitHub MCP have? It has, I think, over like 50 tools. It's way too much for my context necessarily, because that takes up space in your context of your session across with the LLM. And also the more tools it has, agents just start getting into this like decision paralysis and make really bad decisions of which tools to call. So we have to be very careful which MCPs. We can't just add all the MCPs for everything in our environment into GitHub Copilot and say, oh, everything's perfect. No, it just doesn't work. And we also are missing an orchestration layer, right? There's no way to intelligently route tasks to specialized agents or coordinate multi-step workflows. That's something you have to do. That's outside of MCP. And the final one is that really the real world problems demand agent ecosystems, right? Nothing is a point blank situation in the real world in production scenarios where it's one system. I need to talk to my logging system and my monitoring system and my deployment mechanism and my source code and the application runtime. We have so many things that we need to correlate across. Simply an MCP is not enough. It's a key building block, but it's simply we have to go levels above that. And really, Microsoft have been leading this whole effort right around MCP. And, you know, if we just take a look at it for a second, like not only from what we see here, which is really the patterns of agentic AI, that it's being how they've really defined where AI agents are really beneficial, be it in things like 24/7 coverage, right? To reduce wait times on that initial response to issues. One of the greatest ones in my mind is actually kind of like number 4 here, right? Which is the parsing and summarizing and classifying large volumes of text. One of the greatest things of an LLM is throw it logs throw it a stack trace from a Java application and say, but what's wrong here? Humans don't understand it. LLMs understand it perfectly. And you get responses really easy, right? And agents are great at these types of things. But Microsoft not only are the leaders in MCP, right? Creating amazing MCP servers, the agent side integrating with these MCPs is where Microsoft really shines. Because I can tell you guys that on November 28th, I believe it was, or 25th, the latest version of the MCP spec came out. And once again, they changed the way that authentication should be done for MCP servers. It moved from whatever, different thing, dynamic client registration to CIMD, and it doesn't matter what the old changes are, but there was evolution. As mentioned, it's a constantly evolving spec. Within 1 week, it was in the public release of GitHub Copilot, the support for CIMD, right? And that is why, again, if we go back to what Yaniv did with the API management of bringing an API into MCP, if you're writing your own MCP servers, you need to deal with all that in the back end. If you build the REST API and expose it when relevant, but expose it through API management, Microsoft are leading this effort of really pushing forwards the spec. They can handle that instead of you needing to continuously re-architect, invent the wheel to change things in order to fit your use case, right? And when we really think about this in practice, there's really this idea of agentic DevOps, right? And agentic DevOps is really, again, we want to get rid of that tool paralysis. We want to create dedicated agents that are great at a request agent. How do we make requests in this organization? What standards do we have? An architecture agent, coding agents, testing agents, right? Things around security, right? Maybe just a policy enforcement agent that works with Azure policy and Kyverno or OPA or whatever it is and actually enforces policy across our industry, our company. We may have an SRE agent, right? That deals with all of our production incidents. And this is what's critical, is that we need all of these agents. And then typically we're going to want also some orchestrator agent that goes and calls these different agents that each has their own tools. And that's really where the world is moving towards, these large orchestrating agents that just orchestrate to different agents that talk to other agents that end up, yes, the actual data is called through MCP, but we have dedicated agents for each thing with specialty. Each one may use a different model because there are different models that are good at different things. Each one has a different system prompt, system tools, all of that are available to it, right? So let's talk for a second about really where Microsoft is with this. And I want to introduce the new Azure Foundry, not Azure Foundry of the new Azure Foundry, right? Was Azure AI Foundry, now Azure Foundry. And let's talk about what's new here, really. And the Azure Foundry really breaks up into a few different systems. At the core of it is the control plane. One of the challenges in the AI world in enterprise that everything is disparate, everything is all over the place. I have no centralized governance, centralized policy, and centralized visibility and monitoring. And we get that through the control plane. And that is the baseline on which now all of our other services come. Whether it be, we'll go through some of these, right? But really the idea of every model, right? This is that models block. And we can host here or proxy out to any model really that we care about. It's the largest marketplace of models that we can choose, be it basically almost everything from Hugging Face or Azure and Microsoft specific models that they've built to even, go and run any of the Claude models, which are newly added into Azure Foundry. And we can use any of Anthropic's models now, again, through this same system sold directly by Microsoft, right? There's over 11,000 models here, which is amazing with unified access and enterprise-ready environments. We then have our agent service, right? And the Foundry agent service is amazing because it really is open by design. And the idea here is how can we easily expose MCPs to be able to be used in these agents, build agents and host agents. So we can build agents, simple agents in a declarative model. We can go and actually design our agents, and we'll see this in a demo in a bit, but we can actually build an agent, connect different MCP tools and MCP servers to it. We can use different agent frameworks if we wanted to within the platform, right? It's extremely powerful that we can host these agents in a very simple, elegant, and enterprise-ready way. And then we can even go the level above that and build those multi-agent workflows to really build out that, agentic DevOps or agentic whatever we want ecosystems where we have all these specialized agents working in harmony together. And it even goes a level above that where we get one-click pushing of this to Microsoft 365 or Azure 365. We can create Teams apps at the click of a button that all of a sudden I have a Teams bot now of my agent for my entire ecosystem exposed to me. Now that may be a workflow with 35,000 agents in the backend. Single click, it's exposed through Teams now to my entire organization to use. And that is extremely powerful here. And we'll see some of the demos of that in a bit. This is really that multi-agent workflow, right? Where I can have a starting point, it can ask questions, we can have loops, we can have if statements, we can have conditionals, we can have whatever we need with these multiple agents being called from one to another, and each one we can see, or I can choose the model that I want. So for certain things, log analysis, maybe I want one with a really large context window, but if it's a coding agent, it really should be using, let's say, the Anthropic models, which are today in the industry viewed as probably the best models for coding. But then I have specific ones that are great on security, and I'm going to use those models. And that's a huge benefit as well in that context, right? Foundry Tools has over 1,000 tools from public tool catalogs from Microsoft themselves, as well as from partners. And that's huge because this is a marketplace of basically, what MCP do you want? Just add it to your agent. You don't need to deal with how do I host this? How do I run it? Where do I set it up? How do I do all this? All this is handled for you by Microsoft. You simply come select which tools you want from the catalog. And you can see we have Atlassian here. We have Box. We have GitHub. We have a bunch of Azure ones specifically. We also have the Hugging Face MCP server, right? Use whatever MCP servers you want from the ecosystem, all in a really simple way. And obviously we can bring our own as, we will see in the demo. Right? Huge amount of ecosystem tooling brought in, not just Microsoft. And that is the key. It really is an open ecosystem. Microsoft want to allow us that full capability of AI across our entire ecosystem. And it's not a walled garden or anything that only Microsoft tools work. Anything goes here. And that's what's really amazing with the power of the enterprise readiness wrapping from Microsoft, right? The final thing I want to talk about is Foundry IQ, which is really critical. And one of the challenges that we've always seen is MCP versus RAG, right? There were 10 million blog posts on what is better, to do RAG or to do MCP. And the answer is the two are not contradictory to one another. And we should be able to use both. The issue with RAG in many situations is that I go and ask a question and either my chunking was bad and my indexing was bad. So in my database, it doesn't find the right results, or my query against it was bad and it doesn't give me the right results. So I'm not getting that data. On the other hand, MCP tools can be very expensive when I have to pull live data all the time. I have to parse it. We get a lot of benefits from RAG in certain systems with semantic searching and things like that. So how do we really fix that? And that's this idea of agentic RAG that Foundry IQ brings to us. And the idea of Foundry IQ is that point agent to one knowledge base. How do I connect you to one knowledge base? That knowledge base has a bunch of sources in the backend, which can be both data sources, RAG, or MCP servers themselves and the tools. And we only point our agent to one knowledge base, though. And what ends up happening is with this agentic RAG engine is that we come and send our query in. And basically what this will do is in the IQ, it will come in, it will query plan, right? It will plan that query for us. It will decide which sources make sense to ask the question. It'll go whether it's index data, whether it's actual remote MCPs directly. It will talk to those systems, retrieve it, re-rank the results based off of what it received. It'll iteratively search until it thinks that it got to a good result for you. It'll merge those results and synthesize the answer and send it back to you. So you don't need to deal with these multi-source RAGs. Let it all be handled for you with the ability to plug into really any system in the back end through MCP or RAG, which is extremely powerful, right? And this is that idea of the control plane, again, wrapping it all, giving me that end-to-end visibility and governance across my platform, right? Which is key. We can get that observability, we get agent controls, we can secure all of our agents, we can command our entire fleet from one place, and we can connect any agent basically because we have the full support to A. So any agent that implements the agent-to-agent protocol, we're able to integrate with as well. So with that, I want to pass it off to Yaniv to really just show us some of this, live in an environment. Let's see how we build agents with multiple MCPs.
Cool. Thank you, Scott. Let me share my screen. Okay. So here we can see the Foundry. Okay, so this is like the new interface, and the first thing you're seeing is like, let's start building from scratch, right? So it gives you that awesome menu and simplified kind of experience. And the second thing is like your endpoint, your key, go ahead and do programming stuff. Have the entire thing built in API, even stateless infrastructure as code tools like Terraform and Bicep and all of those good stuff. But essentially, everything you can do inside the UI, you can basically do with an API-first approach. And that's an awesome thing, right? Microsoft has really taken it to the next level. So when we have the home, right, which is the screen that you saw, we have the discover, we have the build, and we have the operate kind of lifecycle of the entire thing, right? When we do the discover, we have all these catalog of models that we can select from, and then get some metadata experience about the models themselves, and then compare performance from actual usage on the platform between different models, so we can know what we're going to expect when we're using DeepSeek or we're using the Claude family of models, right? It's Opus and whatever. The other thing is like the tools, right? So we have a curated catalog, just as Scott mentioned, of tools that you can use directly from the catalog itself, with all of those amazing Microsoft ecosystem and partners that have built in tools and integration with both MCP protocols and other protocols as well, directly from the system itself. And then we have the templates, right? You don't have to start implementing everything from scratch, right? You have your template for existing agents, for workflows that we'll see in a minute. So you can basically already provide value really, really fast with this system. When we go to the build tab, we can build our own agents, right? And give it tools, and we'll see in a minute. Fine-tune models, add knowledge bases, and essentially work with the system to provide value for the organization really, really fast, right? So when you build a new agent, you basically need to select the model that you want to use in order to provide the instructions with the user itself, interaction with the user. You can build your tools, right? So right here, I have my pet link, as we saw in the earlier demo. I have GitHub as well. When I click on add, I can use other MCP tools that I have already integrated within my platform, or select a new integration from the catalog that we saw earlier, right? It can be either tools that are generic, right? So code interpreter or file search or whatever, or we can take the catalog to basically select an already built integration for, let's say, with Atlassian, with Jira, if I want to integrate my workflow with those kinds of tools, or even custom tools, right? So it's an open API tool or in a custom MCP hosted on a different place. So essentially, we can take the MCP that we hosted in API management step earlier in the latest demo, and then use it as a tool inside the agents that we are building with our tools. And this is what I saw that did with the pet clinic and then the MCP. So basically, you can give it the MCP URL, and then you can provide the authentication mechanism. So we support OIDC, OAuth authentication pass-through, right? So you can pass credentials directly from the user itself. Entra, if you want to integrate with Entra, or even unauthenticated if you like that kind of risk-taking, right? So we can both add custom headers for authentication if you want to give it like custom tokens to authenticate with different servers if you don't have a standard kind of authentication mechanism as well, or you can manage it through Entra itself, right? So here I set up the GitHub as well, as you saw in the earlier demo. And we have here as well the knowledge. So as Scott mentioned, I can connect it to a Foundry IQ, which is the AI search engine with all of those good stuff. Or I can set up an external vector space to provide knowledge for my agent itself. One of the cool things that we have is the memory, right? So we have here in the platform built-in context memory for the agent to basically not only use this session to work with the user, but rather use memory stored for other sessions that the user has done with the agent itself. And of course, guardrails, right? So I can add security controls, so what my agent can answer about, what my agent cannot answer about. So basically restrict the answers that the agent provides as well. And all of this is like a code-first approach, right? So I can do the preview of this in a chat. I can do it with YAML, right? So I can orchestrate my own kind of lifecycle management for my agent, or code, right? So I can use the Python modules or JavaScript or .NET or Java or whatever to work with the platform itself. So if I ask a question about, the GitHub, so what repositories are available are mine? Let's see if he knows. Okay, so now he wants to use the GitHub MCP, selected the tools. I want to approve it right now. But of course, I can also do it automatically without actually approving every tool usage as well, for instance, in the demo. So basically, he's now used the MCP, and the agent has detected that I want to use the MCP, and then use the tool itself to work with my context, with my credentials, right? And I can save the version of the agent. I can preview it, so we have a nice page to work with it directly in the browser. So I get this page to work with the agent itself directly without any kind of work that I need to develop my own custom front end. Or I can publish it, and as Scott mentioned, I can publish it directly to a Teams application or Microsoft 365 if I want to expose this agent directly to users from this interface without doing anything. So now I created two agents that are based on applications that we saw in earlier demos. One is the pet clinic agent that has availability for the pet clinic tool. And the other one is the pizza ordering one. And let's see how we integrate those two in a nice workflow. So we have a built-in workflow mechanism to orchestrate multiple agents in a single place, right? So I can create my own workflows. And if I show you the templates, like let's start a new workflow, we have templates that you can start building your agents from, right? So you can start on blank. You can use a sequential workflow. You can use a human in the loop or a group chat, right? So you can basically have the output go back to an orchestrator and then kind of finance your learning itself. So I selected a human in the loop kind of integration. So you can orchestrate your multiple agents. So you have tools like if else, you have loops, you have ask a question tool. So basically the workflow itself uses both if else and uses the interactive session with the user to ask questions, right? So let's say I want to start working with the agent itself. And I want to schedule a vaccine meeting for my pet Pikachu, right? It's my actual dog. It unfortunately already died, passed away, but it was my dog. So so let's say I want to ask my agent to schedule a visit for Pikachu today for vaccines, right? The amount of time that Pikachu got vaccines is like a lot. So now we're asking the first agent, which is the pet clinic agent, to schedule a meeting, right? So he scheduled a meeting for me with the vet to vaccine. And now he asked me, do I want a pizza? That's a nice question. Of course. So you can see the debug flow, right? I can see the state of the workflow itself. Oh, so now the agent prints out the menu items, the available pizzas that I have, and their prices, right? So I can select from the menu which kind of pizza that I want. So I like the
Not a
Hawaiian pizza.
pizza place, Yaniv.
Yeah, sorry about that. Let me fix this. Yeah, but I will take the kosher one, the Hawaiian. I like pineapple inside my pizza. I'm a strange, Italians will say I'm they will kill me. So I ordered a pizza, and let's see that the agent will order the pizza for me. Okay, so we now order the pizza, and I can see in my interface that I have a new pizza order for preparation inside the pizza place, right? So this is like a multi-agent kind of orchestration example that we have with the API management, exposing both an API as an MCP server, and we have an actual MCP server exposed as an endpoint through the API management, both exposed as an agents orchestrated by the workflow tool inside the Foundry itself. And then I can do traces. So I can see all the threads that were opened with my users and then debug those kind of threads and monitor the activity of the orchestration itself, right? So you can see the token usage, you can see the operational metrics, and this really brings it home with what Scott mentioned about the control plane itself. And of course, evaluate, right? So I can throw to the workflow itself, I can throw a flow for the user and then expect the results and then compare it with the actual usage from the Foundry itself, right? So I really, really, really enjoy this tool. And of course, we have the operate, right? We can see like an overview of what is happening in all of those agents in my entire project. And that's like a really, really, really cool solution. Right?
And obviously, we can ask AI about our AI platform because there's a Copilot built into Azure Foundry to ask questions about Azure Foundry, which is really
cool. Yeah, of course. So if we're going to summarize it, and Scott, please take it away.
Yeah, really. So I think the first point here is, right, MCP really does unlock that system access, right? In an AI-driven agentic world, we need that standard, and that's what MCP give us. But we have to go beyond MCPs, right? True AI adoption really demands these purpose-built agents and the multi-agent orchestration, something that we get really, really well in enterprise grade from Microsoft in Foundry, right? Microsoft provides probably the most comprehensive tooling for the entire AI ecosystem, whether it's from building, securing, and maintaining AI workloads across all levels, right? What we just saw in Azure Foundry with the workflows seems very similar to the name that everyone talks about these days, N8N. What's the difference? Yeah. It's backed by code. It's built in YAML. It has the enterprise-grade integrations from Microsoft. So you get that same, what you see is what you get, right? You get that same WYSIWYG, drag and drop type thing that everyone loves, but you can also do it as infrastructure as code. You also get version control. You get deep integration with the ecosystem. You get better authentication. You get all of that handled for you. So it's taking what the industry is doing. It's not saying what the industry doing is wrong. It's saying, no, the industry likes this, great, but let's build it in an enterprise-ready way. And Azure Foundry is platform agnostic. This is very important to note. everything we saw in Azure Foundry, there is a very well supported and documented manner for how we connect this to, for example, an on-prem environment or environments that may be in private subnets and things like that. We have the ability to connect this anywhere. Azure Foundry is not only for things running in Azure, it works with any tool and can connect with systems running anywhere in the world. And agentic DevOps is achievable for every organization through things like Azure Foundry, which really unlock that capability, which till now, the idea of building orchestration agents and 35,000 agents under was difficult. Now it's within everyone's hands reach, right? It's just a matter of defining the jobs, defining the tools. There are thousands of MCP servers out there today. It's finding the right ones, integrating them. Most of them probably exist already in the tool catalog from Azure Foundry, and those that don't, you can either build them or bring them in and really come to that agentic DevOps, agentic operations mindset and reality.
Yeah, totally agree, Scott. So with that, I think that, the next thing that you can do is like contact us if you have some information or queries about that, what you saw here, or questions about MCP. I think that, we can help you to expedite both the orchestration and creation of agentic DevOps. And I think that both of us have seen some really cool implementations in the field already. It's an evolving world, right? So it's not the end. As Scott mentioned, even the MCP spec is not really finalized at this point. It's changing like every 2 weeks, right?
Exactly. Right. And same thing goes for A2A and the questions of which protocols we use for there. And really, I just want to stress the fact Microsoft are leading this effort across the entire world, right? Not that I like to say things bad about others, but like Microsoft have implemented every feature of the MCP spec in GitHub Copilot faster than anyone else. There are key features of the MCP spec that are not implemented in some of the most common tools out there, agents for coding, for things like that, that certain features that are very important that have been asked for 9 months have been out in the spec are still not out in certain tools. Within 2 weeks almost, I think that there hasn't been a single feature in the MCP spec that within 2 weeks isn't in Microsoft's ecosystem. And that is a huge, huge statement, I think, of Microsoft's dedication to this world and the ability for us to trust what they're building. Not only is it great, but that they're really also staying up to date and that we're not going to be stuck behind because we chose an enterprise solution, right? There's always that thing, I'm going to go with the open source because they move the fastest. Actually, faster than open source is what Microsoft are doing right now, because most open source agents don't support all of the things that Microsoft do today as well. And that's a key factor when we're building out these decisions. And how we think about it is Microsoft makes it easy to get started. That demo environment, that POCing, that prototyping, really easy through that start building option, right, in Foundry, all the way to we can manage this through infrastructure as code, version controlled, enterprise authentication, enterprise integrations that we need when we bring this to production. I don't need to prototype in one thing and then go somewhere else and build a whole new thing in order to get it into production. We can, from the beginning, really work in the same platform and gain all of those capabilities simply, easily, and securely.
Cool. And with I think a minute that we have, like, we would like to answer some questions if you do have them. So I will stop the sharing right now, and then let's see if you have some questions.
Yeah, I see there was one question for you, Yaniv, from Tamar. Can you help me get some tokens?
Sure. I mean, yeah, we can try. Like, you can start out with Azure with like $200 credit for free. So open a new account, and then you can use the OpenAI models or any models in the Foundry to start with.
Exactly. That's one of the great things is so much of this is possible to be done in the free tiers, which is huge. And because we can do so much of this in the free tier for prototyping, for things of that, it's really easy for a company just to get started, to prototype, to see the value really of the platform.
Yeah.
Okay. How can I use MCP? Let's see, answer live. from Sofnat. How can I use MCP plus agentic for Kate's issues like fix my broken Kubernetes? So I'm sure you have some opinions on this also, Yaniv. I have dealt with this a lot in the past, right? There was the initial tools of like Kate's GPT, right? And all these things, you know, that were created. The real answer is that you really need multi-agent type systems that deal with these stuff well, because in standard Kates, when you have 30, 40 resources, it's not that difficult to build one agent that has a bunch of tools that can go and get deployments, go get this, and go read it. The challenge is that every cluster is different today, because I have these operators and you have these operators and you have those CRDs and you do it this way and I do it that way. And so that's really where there's some great agents out there today. I can tell you that in the world of AKS, for example, Microsoft have created an amazing AKS specific MCP that uses some other projects under the hood to really give you those capabilities. But it's not easy to build it generically. Typically, you're going to have to build that agent yourself with something like Foundry in an easy way, connecting the relevant tools. Because, for example, there is an Argo CD MCP server. There's also a Flux CD MCP server. Now, which one are you using in your environment? Accordingly, you're going to want those different tools, right? Maybe you're using Prometheus, or maybe you're using OTel and you have OpenObserve, right? At which point you're going to use that. Or maybe you're using Azure Monitor, which is where my logging and all that goes into. So I'm actually going to want, you know, my Azure Monitor MCP for Kubernetes debugging, right? Because Kubernetes doesn't live in its own ecosystem. So it's really, there are amazing MCPs for this today, but we need to build that agent kind of flow. Let's say that workflow part kind of on our own today. But that's because every environment is different.
Yeah, I mean, you can't have like a single agent that does it all. And I think you summarized it very, very well, Scott. You need all those tools, and you have a workflow to analyze problems. So you're probably going to have, with the examples that we saw earlier, a log analyzing or a specialty agent to deal with a specific controller or system that you have with within the Kubernetes space itself. Or rather, you want to work with a layer above the Kubernetes itself. If you have a platform issue, then you need to have an SRE agent that knows the platform to basically analyze all of those things within the platform itself. And fortunately, we do have an SRE agent inside Azure itself. For on-prem system, it's going to be a little bit more challenging. But this is the space that we are moving at is an industry, is to have these kind of agents already built inside the platforms to basically choose and select from to work with.
Right, because if you think about it today, if I say like, what's wrong with my application X? Now, that may be an Argo CD application. Now, the Kubernetes MCP knows nothing about how you go from that application to what the sub-resources created by it were, and then what the resource created by those resources, right? We have a deployment that creates a replica set that creates a pod. Fine, that's known. But how about my own custom CRDs, right? Crossplane uses owner references. Crow uses annotations, right? And so there's just no way for a general agent to know that. What we do, though, is you build a simple MCP or an agent where you explain in the system prompt, if it is a Crow resource, this is how you know, and this is how you find the child resources. And then that gets passed off to the actual pod debugging agent, which knows how to look at the logs, look at the monitoring, all of that, because once it gets to an entity that everyone can agree about, which is a pod, great. Now we can actually debug that, there. But all the higher level abstractions and that stuff really does need specific agents. They can be very simple with just a system prompt, but they're needed for that orchestration and knowledge. Awesome. Well, this was awesome, Yaniv. Thank you for all the awesome demos and great insights here. This was
you
fun.
too, Scott. Thank you very much. It was very fun, very good. Thank
Have
you
a great day, everyone.
for having us.